Hello, welcome everyone. Today is May 13th, and this is another of our bi-weekly Kubernetes SIG Apps calls. My name is Maciej, and I'll be your host today. We have quick announcements. 131 release has started officially today. The two important dates for everyone to remember is the enhancement freeze is June 13th. Passing to 14 depending on how you count the time. And the code freeze is July 9th, passing to 10th. The full schedule, including the exact times, is available in the agenda. If you're curious to know the exact timing, when you want to squash your PRs, when you want to get it landed, it's all there. So with that out of the way, I think we can jump quickly to Mihal's two topics for 131 release. Take it away, Mihal.
Okay, thank you, Maciej. Yes, I would like to discuss as we start the new release, two graduations that I would like to move forward with in this release. I actually discussed this already a little bit, especially the issue that is in the graduation criteria for the managed by mechanism. During the batch working group. And I would like to maybe expand on the discussion also here. But for that, I would like to present. I have a short presentation because like the issue is quite complex. So I would like to, so that everyone is on the same page. Okay, I see.
Yeah, you should be able to share your screen.
Okay, cool. So can you see my screen already?
Yep.
Okay, cool. So yeah, basically in this issue, the problem is that when the job finishes, meaning that we have already the failed or complete condition, the number of ready pods and terminating pods don't necessarily equal 0. And in fact, there can still be running pods. So the API client doesn't have a signal when all the pods terminate, because as soon as we add the failed or the complete condition, we call the job as terminal or terminated, and we don't do any more things. And the scenario where this is problematic is, for example, queue, but I can imagine other job schedulers may also suffer. So the problem is that and because you don't have a signal when all the pods start, queue currently uses for the signal when to start a new job when the previous job is failed or complete, like terminal, then we assume that all the quota is released. But this is not necessarily true. Pods still can linger, and as a consequence, they can like the pods of the new pod of the new job may not be started on time, or may take, let's say, significant amount of time to start, may then violating some timeouts, etc. Or cluster autoscaler can kick in. And these things we observed. So maybe they are not like super problematic, like high priority, but that's a separate issue. How, but it's a real issue. Now. So that's one side of the issue. Another, maybe this wasn't explicitly raised by users, but what we do currently is we don't even add the failed or complete conditions as long as we know that the job is doomed to fail, let's say, but we still wait for uncounted terminated pods to be empty. And this is needed for technical reason, so that because in this field, in the status, we track if there are still some pods for which we need to remove the finalizers. So the API client currently doesn't get any of the two informations, like doesn't get the information as quickly as possible when a job is doomed to fail, because we need to wait for this field to be cleaned, and then more importantly, doesn't get a clear signal when the resources are freed. So yeah, this is slide summarizes the client perspective. So we would like to have these two things. So being able to know as soon as possible when the um, job is doomed to fail, because some clients only care about that, and they just need to know as soon as possible, is it failed or complete. But currently there is this delay, and then also this that affects queue. And currently, yeah, both of them are not fully satisfied. So this slide summarizes the context. So this is the issue. Now, the issue was actually originally discovered when working on the managed by CAP. So in the managed by CAP, we allow or open up the job API so that external controllers can reconcile the job API. And to do so, we wanted to add some additional validation rules. And one of the rules was that um, we were to expect that these two fields, terminating and ready, are zero when we say that the job is complete. And actually, most of or all of the developers like this past reviews the validation rules, and then later on by accident it turned out that it's actually violated the rule, which also shows not only that there are this currently this issues that affect client's perspective, but also that it's kind of hard to understand when the fields are zero already, because again, the validation rules like past reviews and me included were thinking that that we are actually zeroing these fields before marking job outcome. So this also shows like some level of complexity here. Another related thing is the pod replacement policy. So actually this field was introduced by this CAP pod replacement policy in order to, like, maybe this wasn't, let's say, the main goal of the CAP, but additionally we wanted to this field, and one of the goals, and mentioned, it's also mentioned in the story for the CAP, that we want to in this field so that we can work towards solving the issue with quota management in queue. And this to some extent is solved, let's say for the, because the pods can be deleted, let's say during runtime of the job, before the job is failing. So these scenarios are covered. So the only remaining is when the entire job is terminating, and then we are we don't give to the clients the signal because we stop reconciling. And also it's related to the pod failure and success policy caps, because they introduce the conditions. Why this is related? Because let me jump in. Yeah, one of the approaches that was proposed by Aldo to move forward with this issue, it is to delay declaring completed or failed until all of the pods are finished. So meaning that we give this way the signal for B. But as mentioned by Aldo, this is potentially a breaking change, and then we could mitigate with this. So in principle, it solves A and B, and one could even claim that it's like ideal solution, because I think at least about this as an ideal solution, because, for example, first of all, we solve A because we give the signal to the user as quickly as we know as a job controller. We don't have this delay for waiting for uncounted terminated pods to be clean. And we also solve B because we waited. So with setting completed or failed conditions. However, the con is, let's say, the backwards compatible, because we will delay from the user's perspective. So yeah, we need to be aware of that. However, I think that this can be mitigated because the clients, let's say the new version, they could wait for failure target or failed, and this way they could, let's say, even achieve A. And the breaking change is, let's say, not so much that something will fail unless there are, let's say, some timeouts, etc. But mm, because actually this was the solution of delaying implemented, let's say, by mistake during the managed by adding the rule. So the presence of the rule was doing that, and all of the E2E tests that we have were passing. So well, I mean, it depends what we mean by breaking change. From the client's perspective, if they continue to observe only for these two conditions, yes, they will get the answer later, depending on the termination grace period that defaults to 30 seconds, but this can be arbitrarily large. I don't know how large this is in practice. Another approach that was proposed was to continue syncing even after we pass the failed. So this would address B indeed. So we would get the signal because the clients could watch for the ready and terminating fields, but it makes this implementation a little bit tricky from the because if you imagine a client that waits for the terminating to be 0, let's say in queue, then it's kind of risky because if you then run queue against an old version of Kubernetes that doesn't never zeros, then you run like you are waiting for infinitely. So you need to have this tricky enablement of this waiting, potentially depending not just on the miner but also some patch versions of Kubernetes, and this can be quite tricky, let's say, for clients, I think. And also it doesn't solve A, so we still have the delay. But arguably, this is again not super important because yeah, this is something I observed while preparing for the presentation, but it wasn't yet raised by users. But still, it doesn't put us any closer to the ideal state of giving the signal as soon as possible. Yeah, so with that, I think this would be my proposal to move forward. So I really like the approach one. Of course, we need to get agreement, so I will very happy to get your voices. I think approach two is also possible, but my preference, so this is to express my preference. So here, this would correspond pretty much to the PRs. So they are independent of the dependencies. So we need to, in order to achieve this, we need to first of all extend the scope of the conditions. So these conditions are introduced, but only for specific scenarios. So this is only used for pod failure policy, but there is really no issue to extend it and use in other scenarios. Let's say timeout exceeded or backoff limit exceeded, and this is only used for success policy. But there is no issue in principle to use it also for completions reached. At least I'm not aware of any issues with that, and this would be the first PR. Then we would be awaiting for this setting those until all pods are terminated. There is one issue we could also fix. I noticed that when we delete pods because we terminate the job, then we don't count into, and we already issued the delete requests in the sync, but we still don't count even though we have internally the count of how many delete requests we issued, so we know that the pods are terminating, but we don't count them into the terminating counter. We only count currently those that we saw, like so pre-existing deletion timestamp. But this can be improved, let's say, for correctness of the field, but maybe it's orthogonal. And then we could also strengthen the validation in the managed by cap, meaning that we could put in the rule that these are added only if terminating and ready 0. And as I think there were also such voices during the batch working group discussion, this may not be trivial. So this fix I would be in favor of putting the fix behind the feature gate, but then it wasn't obvious which gate this should be put behind. So my current thinking is that I would put this under pod replacement policy or managed by. And the reason being, let's say, this is so that we can have the validation. And then this is because it is, again, providing the API is sort of like one of the goals of the CAP. And the CAP introduces, let's say, two fields. It introduces the field pod replacement policy with two values, failed or terminating or failed. So I would do this, let's say, independently of the value. So this means that this fix as a whole would be included for all jobs which enable on. So gradually, after a time, it will be no opt-in fix. It's just, but this is something similar to what we did for. This is something similar to what we did for the finalizers themselves. Let's say it was a feature like independent cap that was enabled for all jobs. So I would like to do something similar, but just to give us some protection, do it behind the feature gate. But I don't think we need a, let's say, specific new cap for that. I would like to, or prefer for simplicity, reuse and just do this. Okay, so that's all that I prepared. I would like to very much know your thoughts on this plan.
Does anyone have any questions? Okay, I have 3 concerns. I was going through the cases earlier today, and I was slowly leaning towards the first solution that you were talking about. But my concerns are currently around the backup limit. You did mention how you want to handle that one, but I would like to hear a little bit more about that. The same applies for the active deadline. Currently, for both cases, we immediately set the failed condition to true for both cases. And then as a follow-up, this will have some effect on, although probably partially, on cron jobs because cron jobs explicitly look at the failed condition of a job, which probably is only limiting the cases where you're running non-parallel cron jobs, which means it explicitly has to wait for the previous one to finish before starting a new one. But all other cases are probably not affected.
Right. Okay, so let me maybe start with the cron job. So for the cron job, actually currently, as you say, we are waiting for the failed or complete. But the failed or complete, if you have a job that is being deleted, currently is sort of hard to interpret because you don't have, it's not as soon as possible as the job is doomed to fail or complete. I can elaborate on that in a second, but also you don't have a guarantee that the pods are terminated currently, and I'm not sure if you would like to have this guarantee in in cron job, but I assume you don't want. So in cron job, I think, I mean, because currently you don't have this guarantee. So the closest in the cron job would be to wait for this and wait for this. Then maybe we have a separate spec field that allows you to control, and only if you, for example, use cron job to also sort of manage your resources, so you don't start a new job until the previous resources are fully freed, then maybe you could have in cron job wait only for that. But I think the closest to the current would be to wait for or of the two.
Right, that's basically what we would have to figure out, because and then as I'm thinking through it, only for the cases where you're, like you said, when you're managing resources, not to run the new one before the last one, although the current mechanism does not have those guarantees. So theoretically, we will improve the situation with the first approach. Um, I haven't made my mind on that one, but I'm curious about the backup limit and the active deadline. I'm worried that we might have some conformance tests around those, although I'm not 100% sure. I haven't checked yet.
Okay, sure. So for those, we don't really actually. You said that we said the failed or complete conditions. Let's say failed for simplicity. You said we set the failed condition as soon as this happens, the backoff limit is exceeded. But this is not actually fully true, because if it is exceeded, then we still wait for uncounted terminated pods to be empty. So at the level of code, I can show it, but maybe this would be a distraction. What we do is or maybe I will show it quickly. Um, okay. Ooh. Okay, so when we said that the backoff limit is exceeded, we don't really set the condition necessarily, but we set the internal variable finished condition. But this is not necessarily used. So later we have this checks for this is where is this? This is, if my memory is okay, then this is probably here. And then we will, yeah, it's here where we check, even if we have the variable, we will only use it if the job is finished. And this, we say that it's still false if we have the uncounted terminated pod. So this is a way to delay, because again, we need to make sure that there are no finalizers left. So we need to first purge the finalizer, and this may mean that we, in fact, even currently delay delay setting the condition. So if it's not only if it's finished, then we flash. Otherwise, we don't flash. So we may not mark it as finished using the condition. It's a little bit complex, but yeah, we will not flash the
Yeah,
status.
okay. Can you prove that last statement with a, I don't know, test case or something like that? If that's the case,
Sure.
that would be nice. I mean, that's probably the backup limit and the active deadline are the only two major blockers that I would say. But if we can prove that the current mechanism are, um, working like that, then I'm fine with the first approach.
Okay.
Because like I said, I was going through all the cases in my head earlier today while reading through the issues, and yeah, I think it's a reasonable approach. We just need to make sure that the backup limit and the active deadline seconds are maintained. If they are not, then definitely the failure target will improve the situation because we will immediately let the user know that, oh yeah, by the way, you already exceeded. It'll just take us a couple more minutes to finish this off. And then the third one will be the cron job. But that will be, and probably that's something that we'll have to figure out in uh, in one of the caps. I don't know which one. Uh, Figure out because this will only apply for the cases that are, I can't remember what off the top of my head what is called the policy, but basically that the one that does not allow. Okay, that's the forbid. Forbids concurrent runs for the concurrency policy. That's the setting. Yeah, so because in all other cases, in the replace and the allow, that will not change. Only in the forbid case, this might have. So it will be good to figure out what the current state is. But I'm pretty sure that this will also very likely be only for when you have the backup limit and the exceeded active deadline seconds. But I'm mostly inclined to leave the cron job as is, meaning that it will only react to the final failed state, failed or complete, and not the partial state.
Yeah. Although this will be a slight change in the semantic of the cron job, because currently, assuming that I'm correct about this first, we don't have the guarantee in cron job that the pods are terminated.
I think the major difference is that the current logic, even if it's delayed, it doesn't depend on the graceful termination period. It only depends on how fast we are able to remove finalizers. I think we might remove finalizers even before we finish even before we observe the pods finished. I don't remember if we even wait for the pods to finish. I think we might just be removing the finalizers right away. And if we are doing that, then
well, that's your final moment because you're not guaranteed to see the pod anymore after you remove your own finalizer. So that's literally you're in a termination state. Once you remove your finalizer, that is potentially a last time you're gonna see this particular pod. So you should be
that is true.
counting this as removed. It might show up for a little bit longer because, for example, there will be additional finalizers that will take a little bit longer to get removed. But in the most optimistic way, you're the last one, which means it gets removed right after your finalizer is removed. So if you have some concerns, I would probably do one more check around the finalizers removals, because that sounds like that there might be some issues over there as well.
Right. So I guess the question is
Yeah.
when are we removing the finalizer, right?
Yeah. I guess the only question is probably figuring out where we want to place this particular check under. If I remember correctly from looking at the agenda, you are targeting the pod replacement policy. I have way too many windows. Pod replacement. No, pod failure policy. You're planning. Just I think the same. To GA in 131.
Yeah,
that
so
would
this
mean,
is another topic.
yeah.
I haven't covered this yet. I will want to have, let's say, 5 to 10 minutes, unless it's related and you want me now to go here. But I wanted to first, let's say, have some discussions
Yeah,
here.
okay. So maybe probably I would just focus on the managed by. If I remember correctly, managed by is beta currently.
It's
Because we
alpha
run,
still.
it's still alpha. Okay, so we could have one another alpha for the managed by and keep it there and then introduce this particular change and then consider the change. Philip, go ahead.
Yeah, I have mainly questions about the forbid cron jobs and the pod replacement policy. So you said you will not introduce like any new field for the pod replacement policy, or that you will not use any of the current fields, right?
Yes, I would do this for all the jobs because I think, let's say, this is the ideal state. It's just about how we get there. So for a time being, I want to protect the fix by some feature gate. But yes, ultimately, I think it should be enabled for all.
Yeah, so like if this is like not configurable or we are not planning to make it, so if I look at the forbid cron jobs right now, it seems that once the job completes, like the next one will run right away. So then you could have like two use cases. Like one use case is that the person wants to run it right away, and the second one is concerned about the resource usage. So they might want to keep waiting until all the terminating pods are away until the next one runs, so they do not go over the quota.
Right. Yes, so these are these two these two possible interpretations from the cron jobs perspective. Yes, and
yeah, but theoretically, if you look at it, it still applies only for the backoff limit for the cases where in backoff limit or or active deadline seconds are set, because only those two cases have potentially, and that's something that Michał has to double check. Only those two cases are the only ones that potentially are setting the failed condition sooner than what's being discussed. So that's why the proof for those, if we actually, because if we delay setting the failed, even in those both of these cases, then even cron job will not be affected. If we are indeed setting the failed ahead of time, then cron job might be affected, and we'll want to figure out what to do with that. So a lot will depend on that proof that Michał is to put together. Does that make sense?
yeah, with one comment that actually not just backoff limit and exceeded deadline, we also have another mechanism now with the pod failure policy. We can use fail job action. So for example, if a pod has some certain exit code, then we would also terminate the entire job. And then again, we would delay setting the failed condition until all the finalizers are removed. But in that case, we will set the failure target condition. But still, from the cron job perspective, it's the third case that we said failed.
Yeah.
But the point is that in all of these cases, even currently, when the new job is created, the pods from the old job can still be running. I will double test that, but I'm pretty sure that's the case. It's just another manifestation of the issue that we have. Let's say that, yeah, that at the moment when the job is failed, we still can have terminating and ready greater than 0. And this means that, yeah, that when the new cron job is scheduled, the previous one still can have pods currently. Now, if we eliminate that, we have two choices for the cron job. One is to watch for that, to know as soon as possible that it was doomed to fail, or just this. Now, semantically, this would be closer to what we do currently, but maybe this is actually safer from the cron job. Or maybe, as I think Philip alluded to, maybe we want to have the configuration at the cron job level that would allow us to choose. It's something, yeah, we could consider, but
Yeah, can I? It's hard to track all of this, but yeah, you could either do the cron job or you could configure it through the job itself if you would enhance the pod replacement policy. I think the best would be to see like some kind of a table and to see all the features and how they interact, and to because like it's hard to imagine all the combinations.
yeah, I'm thinking.
I would start with approve for active deadline seconds and backup limit. That will allow us to make the initial decisions. And then once we have those initial bits, we can gradually think through whether we want to expand or not.
Okay, so about so we will probably continue the discussion about the details, but as I understand, the overall solution with this is okay, but we still need to figure out the details how to handle this from the cron job perspective, and this could mean a new potentially we will discuss a new field in the cron job to choose the semantic, or we will decide on one. And potentially this also impacts where do we swipe the fix under. Is it just managed by or managed by or pod replacement policy, or maybe pod replacement policy for a specific value of the field? Again, I would prefer to do this fix unconditionally because let's say we this is what we want to have ultimately. It's just that for historical reasons getting there is problematic, but I don't think that I think coupling this fix to, let's say, pod replacement policy failed could be misleading, because I think the semantic we want independently ultimately, and it's just a matter how do we protect, let's say, if there is a bug so that user can disable that. But I think this is conceptually similar to what we did for pod tracking with finalizers that is now enabled for all jobs. And this was like a feature that is now, or a fix, you can think about this, that it was just a fix for pods being garbage collected. It's enabled for all, and it had a feature flag. So maybe we could just use this feature flag or of these two feature flags to put the fix, but still I think at the end of the day we don't need to have configuration at the job level, maybe at the cron job level, to decide if we have again look for this or just this.
Cron job is if anything, we'll just add a new concurrency policy. It was written such that we can just add additional concurrency policy, and it'll wait for either or both or just the one that we decide. So I'm less worried about the cron job bit. You wanted to cover the pod failure policy as well?
Yes. So as you know, I started the work on pod failure policy. It was 1.26 alpha, 1.25 alpha, then 1.26 beta, and it's beta since then. There are some important fixes. So the one thing is that what in pod failure policy we require is that all the pods before they get deleted, they are in the terminal state so that we can inspect the exit code. And this wasn't guaranteed by the kubelet until 127. In 127, we had this sort of important fixes in kubelet to ensure that every pod is moved to that is not going to be restarted, that is moved to a terminal phase, and this is needed for the feature. This created some issues to the daemon sets or stateful sets that didn't support well, because this means that some of the pods may transition to succeeded since 127. And the daemon set and stateful set didn't have good support, weren't prepared for that, but we moved fixes. So now we have, let's say, 3 releases with the fix, and there are no issues to me. So I would like to graduate this to GA, and people already start building on pod failure policy. We have the Abdullah's CAB and Daniel Vega-Meyer about the reason. And I think other projects like Kubeflow want to use. So I think it's good if we graduate to GA, and then if others can still build on top and create new cabs. But also my reason is that it's quite complex feature that is present in kubelet and every component, let's say, because we add the condition, adding the conditions, termination, disruption target that are added in many places in the code. So maintenance of this might be tricky if we let it for too long to linger in this beta state. So I would like use this 131 to move it to GA, and then simplify conceptually that this is the status quo. Any thoughts on that?
I think as long as there are no major issues, I don't see a reason why we would not push this to GA.
I don't think there are any issues pending, but yeah.
Go ahead, Philip.
Yeah, and just if it'd be good to check if there are any concerns regarding the failure target condition as we described just earlier. If we have some consumers who expect it not to appear, and then we will add it in every case for the terminating pods issues bug.
So can you rephrase? I mean, I'm not fully sure.
So today you only get the failure target condition when you use this feature, right?
The disruption target, yes.
No, I mean the failure target.
Yes. Mm-hmm.
The failure target. So unless you use it, this condition is not set. And if we have like some consumers who depend on this feature and expect the failure target to appear, if it could have impact on these consumers, if we introduce it later for the terminating pods issue, that we set it in every case, even when the pod failure policy is not used.
Oh, I see. So there could be, let's say, some clients that don't want the failure target. So maybe for that reason they disable that. But with this fix, we will make it not dependent on or not only dependent on the pod failure policy.
Yeah, I'm not saying it should be blocked by this, but if it would be good to take into consideration.
Mm-hmm. So my idea, yes, was to reuse these conditions whenever this or the or that's yet to be discussed is enabled. Yeah, but I think we can figure out the exact set of ORs here.
Or if we could, for example, it would be like a simple fix to add to this cap or this feature to set the failure target during setting the failed condition, like unconditionally. So,
Okay, so this could be even part of the pod failure policy.
yeah, I suppose. I'm just the random thoughts, but
I don't know. Any thoughts on that from other folks? I wasn't planning to do this like this way, and I hope this wouldn't prolong graduation of the pod failure policy. But it's a one way of seeing. But no, not really, because this is actually not introduced there. This is so to solve the issue, we need both conditions, and only this one is introduced at the pod failure policy, and this one is introduced in the success policy, which sort of shows that this fix is like orthogonal to, or okay, it overlaps with these features, but maybe it's like broader scope. So maybe it's not part of this caps to this caps, I mean success policy and failure target to extend the scope, but it's part of this cap or this cap to extend the scope of this.
I think it's valuable to leave a note in the pod failure policy cap and to put an action required, signaling that, well, if you are depending on failure target condition, you should probably be looking, and you expect it only for pod failure policies, you should be also looking at the reason, right, of the condition.
So yeah, it's a little bit convoluted scenario, but if I understand correctly, then if you are a client, API client that wants to observe failure target, but only added when fail job is triggered, then also check the reason, because just checking the presence of this condition may not be enough. Is it, Aldo, what you mean?
Yes. Yes.
Yeah, so certainly yes. Just adding a node to this cap and probably this cap for symmetry would be good. But I don't think we need to block the graduation of this one because it's achieved its goals. It's just that some of the concepts, like this concept or this, we want to extend the scope. So I think it's job of the caps that are that need the extension of the scope. Okay, so these are all the topics for me. Any other questions or comments? Other concerns? If not, then I think I will have a clear now path to. So first of all, we go forward with this. We add a note that about the extension, but for this we proceed with that. One thing is that we still need to prove, but I'm pretty sure this is the way it works. And then we still need to decide how we handle this in cron job, whether there is a new field or not. And then we need to precisely determine what combination of feature gates will protect the fix. I propose this for now. That was my thinking, but we will see during the cap. So I will open PRs for the caps for the enhancement cycle following these suggestions.
Okay. Thank you very much, Michał. Thank you very much, all. I don't see any additional topics for today. So with that, this concludes today's call. Thank you very much, all, and see you next time.
Thanks, everybody. See y'all later.
Bye.
Thank you.